I don't know if I'm supposed to move this part. Okay. So thank you guys for joining me. I'm really excited about presenting. This is I broke in now what? Linux Manual Privilege Escalation 101. Before I get started, I wanted to say this is by no means a comprehensive guide. This is just kind of touching the tip of the iceberg or scraping kind of like the surface of something like this. Normally, privilege escalation entails several different steps. You might have to combine methodologies that are existing just to gather root. So, who am I? I feel like all presentation starts like this, so mine is really not going to be the exception. I'll do the same. Bachelor's degree in computer systems engineering, senior security engineer with a little bit over 7 years of IT experience. I started, like in the service desk, just unlocking AD accounts, creating them, just adding to groups and all kinds of good stuff, just typical. Red team enthusiast, CCNA, SSB, JPT, CISSB, what? Well, I do have all of its credentials, but like the alphabet soup, it just kind of throws me off. I'm pretty sure there's people here who have like a longer alphabet, but yeah. Definitely, this is gonna make me sound horrible, but out of all the certifications that I have, SSCP has definitely been my favorite. I feel like it's ridiculously underrated. It really gives you like a really good foundation if you want to get started with CISSB, so you should definitely check it out. Experience on incident detection and response. So I think incident response is a lot of fun because with little pieces of information that you're given, you're able to paint a picture. You have to put all the pieces together and all the hints to get a potential answer to what you're looking for. So it's definitely something really fun. Fun facts about me, my favorite color is pink. When I was a kid, I was terrified of Mr. Clean and David Bowie. I know these two characters are completely unrelated to each other, but I remember being a kid and my parents taking me to like some kind of thrift store. Like we were looking around and I saw this David Bowie record and I was like, who is this evil guy? Like, why is he? Anyway, just he gave me nightmares. If you're a blue teamer, why are you teaching me pen testing stuff? And this is something that I've had people asking me at previous jobs. Like even at my previous job, like my old boss was like, you do realize we don't pen test in here, right? I was like, yes. And even my coworkers, why are you trying to learn all this stuff? Like are you seriously trying to become a pen tester? This is gonna hurt your career. And I have mixed feelings about this because if you really want to be a good security operations analyst or understand security operations, you have to think like an attacker. Like if I really wanted to be a bad person, what steps would I really need to take to mess up an environment? I feel like blue teamers are the unsung heroes of this industry. I mean, I'm really not trivializing the work of a hacker or the work of a red teamer, but you're just kind of there playing pretend and just going through a whole entire program. You start an engagement with a client, you go through several steps, and it's a lot of heavy work, but you go home and you're done with it. While a security operations person, you go home and it doesn't guarantee that you're going to have a free afternoon, right? So if I wanted to be a bad person and an attacker, crime doesn't work from 9 to 5, right? So real world attacks can happen at any time, basically. What is exactly privilege escalation? Privilege escalation vulnerabilities are security issues that allow users to gain more permissions and a higher level of access to systems and applications that their administrators intended. These types of flaws are valuable for attackers because they're needed for full exploit chains, but can be overlooked by defenders or developers because of their lower severity scores. So what does this even mean? It's just like a whole bunch of random words. So whenever we think of an environment in an ideal world, most environments should be secure under the principle of the least privilege. So what does this mean? Like if an administrator is supposed to be doing their work correctly and doing their due diligence, they're only going to give users the very bare minimum permissions for them to perform their tasks. They're not going to give them more and they're not going to give them less. For example, Pedro from the front desk or Bethany from accounts payable, or, you know, like Bob and Alice from the marketing department. So they're just going to be able to perform their very basic daily tasks. But this doesn't only apply to end user accounts. This also applies to service accounts. For example, Apache or www, you know, like data, just they're supposed to be having right permissions, but they shouldn't really be able to have them outside of their root folder. So it's up to us to take the necessary steps to gather the permissions that we need to get root. The Bling Ring. Between the years 2008 and 2009, a group of affluent Hollywood teenagers broke into celebrities' homes to steal luxury items. They took as much as they could and they went unnoticed for several months. But what does this have to do with privilege escalation? So I remember reading about this, even though it was like in 2009. I read about it in 2014 and I was just like, okay, people like Kim Kardashian, Paris Hilton, Orlando Bloom, and, you know, just like a whole bunch of celebrities had their houses broken into. And when they interview, you know, like the criminals or, you know, like the people that broke into their houses, they were like, yeah, so we went unnoticed for a very long time. We didn't really look for difficult solutions. We were just like something simple. How would we break in? And we went straight and looked for all the goodies. So it just kind of makes me think one of something in particular. Somebody that is trying to gain access, they have to be sneaky. You don't always have to be looking for the craziest or most outrageous solutions. Just try something simple. And once you're there, you want to take all the good stuff. Security operations is like pen testing, but backwards. I saw this meme long ago and I thought it was really funny. The ugly truth. When I mean the ugly truth is just basically the challenges that you could potentially face when it comes to privilege escalation. It is unlikely that you'll ever find a one-size-fits-all exploit. If you're lucky, and this is if you're very, very lucky, you might be able to customize, or you might just need to change, you know, like typical port and, you know, like your local address, or you know, like the attacker address or anything, just change IP and ports if you're lucky. But a lot of the times that's really not the case. I remember this time in particular when even I was looking at an exploit code and even the exploit was telling me, hey, you might need several attempts to be able to run this exploit, you know, like successfully. And I was just like, this is bad. So in fact, it was true. It took me several times. Pivoting could be a defining factor for a successful privilege escalation. So it just kind of reminds me of Sesame Street, like who are the people in your neighborhood? You have to see who is around and what they're doing, right? Because just because you're not able to find anything that you could potentially consider useful in your current computer, it doesn't necessarily mean that you're not going to find anything interesting, you know, like in the computers that are within the network. Or let's just say that you found a set of credentials, but they're useless right now. Well, you should try them. You have the option to try them on the computers that you've actually pivoted into, or look for web services, see what they're really trying to do and what they're really trying to tell you. Time-consuming and repetitive tasks. As I mentioned before, privilege escalation is not just, okay, I'm going to run an exploit and it works and woo, we're all good to go. I mean, if you're lucky, you can get away with that, but a lot of the times it's gathering information, looking at who are the hosts in your network, looking at particular services that are running, and you have to go through a whole entire list. No security architecture for the actual pen test. If there's no security architecture for the actual pen test, let alone for privilege escalation itself, which is like a whole entire beast on its own. Creating sandboxes for customization, research, and testing. So this is pretty interesting because never, ever test in production, no matter what you're doing. Makes me think, you know, like when you're playing with Hack the Box or Virtual Hacking Labs or PWK, I think, you can get away with, okay, I mess this up, I'll just reboot the box and, you know, like just go get something to eat and then come back and I'll be good to go. In, you know, like the real world, you can really mess up a client's environment and you can get in a lot of trouble. Plus, you want to be able, if it's a kernel exploit that you're working with, you want to be able to test it before running it. Explain like I'm 5. So we're really not going to reinvent the wheel in here. We're just going to go through the basics of each one of the steps in the kill chain. So reconnaissance, we're basically gathering as much information as we can. Anything, just, you know, like port number versions and operating systems architecture, like web services, anything that we could potentially use to gather a weapon. For example, just because we're seeing a port open now doesn't necessarily mean that we could find a valid exploit for it. With punization, we're pairing an existing exploit with a service. So we're just basically saying, okay, I have FTP open. I'm going to be able to find an exploit for this particular service. I don't know why I said FTP, honestly. I've never seen FTP open in production. I'm pretty sure that people still use it. Well, I don't think people still use it, but I'm pretty sure there's got to be somebody. Yeah, it's a super, super old protocol. Like I feel old just by talking about it. Delivery, how are you going to place your payload? Are you trying to, you know, like maybe code injection, or, you know, like if it's an executable, are you going to place it via email? Just pretty much how are you going to send that message? Exploitation, how are you going to trigger that payload that you already placed? For example, I remember when I was just getting started and something as ridiculous and simple as a WordPress application, I gathered credentials and I was able to log in and I placed my payload and I was just like, okay, my payload is there. It's a PHP reverse shell. How am I going to be able to, how come I don't have a shell? So I was there just sitting there with my netcat listener. Why isn't this working? Because I had to activate it. Either you can get an end user to click on it, or, you know, like disguise the attachment into something fun, or anyway. Command and control, well, installation, what additional tools do you want to, you know, like install in that computer that you gain access to? Do you want something to, you know, like gather additional information, or are you going to look at the hashes that are there, or what are you trying, what tools are you trying to install that would potentially give you the results that you're looking for? As in command and control, that's hands on keyboard. Actions on objective, like what were you trying to gather out of all of this? Were you trying to just, you know, like get usernames, get hashes, just get a good look of what applications are installed? Do you just want to write a report? Were you doing all of this just to be a jerk? Don't do that. Don't do it just to be a jerk. Like, always do everything with permission. So. If you watch the movie Hackers backwards, it's about a group of SecOps analysts that work for a TV station and use logs to save an innocent man from going to jail. This is really weird because I remember back in 2012, they had like a whole bunch of these memes, like, if you watch so-and-so movie backwards, and it took me a while to find this meme, but there it is. I haven't seen this movie in forever. Metasploit isn't the best thing since sliced bread. And I know this is the kind of conversation you really do not want to have at, like Dallas Hackers or, like certain places, because I feel like people just get really, really hung up on it. And Metasploit is not good. Like that's like paint by numbers. That's just fill in the blanks. You're not a real security professional. Try harder. Go back to the service desk. What are you talking about? All those, like crazy stuff. But I honestly have mixed feelings. I'm really not here to bash on Rapid7. I've used Metasploit countless times in the past, and I feel like it's a really good tool. I find it really, really helpful. I honestly feel that the only time when you should really not be using Metasploit is unless you're specifically instructed not to use it. If a client tells you, it's going to be very, very unlikely that this happens, but if a client specifically tells you, hey, I don't want you using Metasploit, or if management specifically tells you, you're using Metasploit, you're going to get in trouble, then stay away from it. I feel like it's a really good tool. But some of the challenges that you're potentially going to be facing, like besides backlash from the community, it's you get what you pay for. The community version is really useful, but like if you're looking for integrated cool features like API or API integration or reporting, yeah, you might want to check out the like paid version. Visibility. Okay, for you guys that are actually use Metasploit a little bit more often, think about this for a second. How many times did you actually look at the code or the Ruby exploit? Because I for sure didn't the first time when I was using it. I was just like, yay, I ran my first exploit. This is so awesome. I got a reverse shell. And I was really excited without truly understanding what's in the back and what's happening. Customization requires expertise. And this doesn't only apply just for Metasploit, but it's just for anything that you're doing. Like if you really want to get the results that you want, you have to understand what you're doing. Get to understand what an exploit does. And, like just taking consideration that you would need to know how to code in Ruby. So just to get an idea, these are Metasploit modules. So I feel like it's a really robust tool, but it has a whole bunch of goodies. For example, this is the auxiliary mode in particular. So even though the auxiliary mode isn't really going to give you a shell, it's really going to provide you good hints for you to gather one. For example, like fuzzing or scanning, or there's even an option that is called token impersonation. So what it does, I feel like my chair is like really messed up. Anyway, I should have, like moved my chair when I was getting started. I didn't. Oh my. Anyway, so token impersonation. So what you can do is like once you're in and you find an interesting account, you have the option to impersonate token and basically be able to mirror the permissions of that existing account, which I think it's pretty cool. There's obviously a manual way to do this. For Windows, you can use hot potato, rotten potato, and like they really, really work well. Payloads, which are the meat and bones, like, okay, you are able to exploit a vulnerability, but what are you trying to gather out of all of this? So are you trying to connect directly to that port? Are you trying to get the victim machine to connect back to you? Do you just want to be annoying and pop the calculator? So that's a particular option too. For exploits, those are the codes that we use to take advantage of an existing vulnerability. Another thing is that you really want to have a good understanding of how an exploit works. I remember when I was getting started and I went to ExploitWV and I had a Drupal vulnerability, and I was just like, okay, I find an exploit and I know for sure the system is vulnerable. Why am I not able to get a reverse shell? And I used to get so frustrated, but you have to understand that I used to think all exploits would just give you a reverse shell. Not really. So you have to understand what it's trying to do. They might be able to show you, for example, a hash that, you know, like once you crack it, you get access to the web application, or they might be able to show you like a list of users or a directory that is missing. And that's like I was saying before, you have to put all those pieces together to try to, you know, like gain the objective that you're trying to target. Encoders. This is the presentation that you're pretty much giving to a payload. Now, encoding something doesn't necessarily mean like, oh, okay, I'm unhackable. Like, I honestly don't think that there is such thing as I'm unhackable, but it might give it an additional layer of security, right? It might just make it a little bit harder for them to be able to track you or notice what you're doing or notice that this is, you know, like a reverse shell. And then there is another module called NOPS, which stands for no operators. Basically, a no operator is an operator that does nothing. And why would we want an operator that does nothing? Well, these are commonly used, for example, for memory alignment. If you want to void a particular instruction, there are certain programming languages that they don't allow you to use blank spaces. So that's when you use a no operator. And these are pretty common when you're working with buffer overflows. MSF Venom. It's a tool that allows users to generate payloads and encode them. So the advantages of MSF Venom are it's one single tool. I remember before 2015, there were two separate tools. One of them was called MSF Payload and the other one MSF Encode. So after 2015, they just kind of bundled it up in just one. Standardized command line options. So it's just like a typical terminal that you always see in Linux. Increase the speed. So it's a lot quicker than it used to be. So these are, you know, like for those of you that are not familiar with MSF Venom, these are the type of payloads that you would normally get to see. This is one of my favorites because so I have this friend that I always like joke with and just, you know, like go like, hey, there's a, you know, like there's an MSF Venom payload for me to, you know, like remote into your iPhone. And anyway, so I've tried the Android one, I've tested it, and it's really cool. So, but you like if you're familiar with Linux, you're gonna have a really good understanding of how to, you know, like navigate and browse through the folders. So it's a lot of fun. Another thing that I didn't mention, like I said, I don't want to use the word toxic, but I've noticed that there's a lot of, you know, like, ooh, I'm such a hacker, like, you know, like I use Kali, and I've heard a lot of, you know, like, I don't want to use the word hate again, but people just criticizing other people for using Kali. What is the right operating system to use? Whatever you feel comfortable with. So I personally feel comfortable using Kali, but a lot of people just like using Parrot better, or you know, like there's other people who go like, I just rather download the pen testing framework to whatever Linux distribution I'm using because that's just me. Like I'd rather add an existing functionality to something that I already have instead of overcomplicating things. And that's something really valid. So the payloads that I most commonly use, I should have put most commonly used by me. This is not most commonly used by the community, but these are pretty popular. So this is the way you would create it, .elf and .py, because, you know, like most Linux distribution are really not going to give you a lot of trouble if you want to run a Python code. That's nice and all, but how do I escalate privileges? So I kind of have to give like a long intro. So Linux privilege escalation activity, like I mentioned before, this is not a comprehensive guide. This is just like the tip of the iceberg, or the things that are more like easier to notice whenever you gather your first and, you know, like initial shell. So you have to know your distribution type. I used to say like, okay, Linux is like pretty much like Matthew McConaughey or like Hilary Duff movies. Like you've seen one, you've seen them all. Not true. So applications and services currently running, because you want to know what you're fighting against, or you want to know if there is an application that is currently out of date, or that could have an exploit that you can run, or a very common vulnerability. Weak file permissions. So here's the interesting part about weak file permissions. In Linux, everything is a file. A folder is a file. You know, like a directory is a file. A user is a file. A file is a file. Anyway. So cron jobs, configuration files. If we're able to write going a little bit back into weak file permissions, if you're able to write into a file, you're good to go. You should be able to write whatever you want, anything you want, including a reverse shell. And so for configuration files, a lot of the times when admins are lazy, again, it doesn't necessarily mean that it's going to happen all the time. They might store credentials. They might store hashes, or even if they're really not storing anything that you would consider important, you know, like a configuration file is really going to give you a good glimpse of what version you could potentially be using. Something to keep in mind. It is possible to replace a legitimate binaries with our code as a means of executing them at a higher permissions level. If a user has permissions to write into the folder where the binary is located, then the file can be replaced with a custom payload. So too long didn't read. If I'm able to write on it, I can write whatever I want. And that includes, you know, like the code that would get me a reverse shell. Gathering general information. So I'm really not going to go through the whole entire list of commands because a lot of them, they're just kind of like a dead giveaway. So here we get to see the kernel version, you know, like which Linux flavor. I did not want to say flavor because I know that I'm going to get a lot of backlash for it, but I meant a version, not flavor. Host name, you know, like just basically the name of the computer you're on at that moment. You want to see your current IP, how the local IP is just mapped to, you know, like physical addresses. You want to see which processes are open. That's what netstat is for. You want to look at your routing table. I feel like ID and who I am are used interchangeably. I do that sometimes. etc password, you want to look at, you know, like who are the current users or what users are in that particular machine. And sudo L. So sudo commonly stands for super user do. So just because we don't have, I know that looks weird that I'm looking that way, but I have another screen. So what I'm trying to say is just because you really don't have permissions to run something, just because you're not root doesn't necessarily mean that you don't have root permissions, right? So there might be certain commands that you should be able to run as root. So what I'm trying to show here is, I'm not entirely sure if y'all can see my screen. Doing a sudo -l, it's going to tell me which commands I can run that I could potentially have, you know, like root permissions to. And I'm going to do something as generic as sudo vim. I'm choosing vim because it's just the first one that came to my mind. I'm kind of a nano girl here. I really don't use vim. I don't even know how to use it. And now I'm going to see my ID. Boom, I'm root. Right? So whenever we do a sudo -l, we want to get familiar with all of these applications that are showing us. I mean, this is just an example of standard ones that could, you know, like come across as easy. But if it happens to be, you know, like an application you've never really heard about before, you know, like most common thing, you know, like just like with everything, you want to Google what it is. So let's try with another one. Let's do, for example, well, anyway, I like how everything goes wrong when you're trying to present. Oh, here I am, root. I'm root again. So basically, this is why sudo is something very important to check. What can you do as a super user? So world writable directories and world writable files. The reason why you want to look at world writable directories is because you want to be able to find a safe location for you to copy stuff. If you want to import or, like pull certain tools from your attacker computer into a Linux location, you want to be able to hide a folder where you can safely copy them to. And world writable files, like I was mentioning, I should be able to write on it whatever I want, including a reverse shell. Checking for unmounted file systems, because there is a way to, like exploit those. And these two first commands are pretty much for looking at all the packages that are installed. And here, which processes are running as root. And here you want to see what is currently installed in the HTML, like folder, in case there is a web application that is currently running. So let's see, for example, what do I have in here? I don't really think I have anything that interesting. Oh, wow. And in here, this last command, this is going to help you find all the suitable files. Ooh, the lazy way. So Linux Smart Enumerator is a script that will show you relevant information about the security of the local Linux system, and it also offers levels of verbosity so you can control how much information you see. Like, you don't want it to start spitting random information. You want to really, really understand what is going on. Like, what is the point of me looking at the files that I can write and all the existing users that are there? I mean, if it doesn't really mean anything to me, like if I'm not really able to understand what I'm supposed to do with them. So this is just a very generic example of how the command works. Just kind of running it from the background. Terrible, terrible Linux terminal. So it's going to start spitting a whole bunch of information. So I'm here, does root have mail? Just what can we read into it? What groups I'm added to? So this is just like the typical information that it would look like. So, like another thing to do is find a functional way to transfer this file. You can do it through, like simple HTTP server. Like I said, it might not always be like enabled or available, but this is just something to consider. You have to have a folder where you can safely write to. Like if you want to copy all your stuff, you have to find a location where you can safely land. If you see the 200 status, it just means that it was copied correctly. So this is what it would look like. This is a user that I created just because I was testing it. I was bored. Fantastic beasts and where to find them. Kernel exploits. So make sure you have a good understanding of how the vulnerability is exploited. Like if you want it to work the way you want it to, you just have to understand what is it trying to do? What is the exploit telling you? What is it trying to accomplish? Validate that the exploit works as intended. Never test this in production. Change the code based on your target, source IP, directories, and ports. If you're lucky, this might be the only things that you might have to change. But I'm pretty sure that, like you might have a missing library, you might need to have another installation on your local host to be able to run it. Look for special instruction side notes or indications of sections that need to be modified. Honestly, you really want to read the exploit. Don't just run it blindly or stupidly. You want to understand what it does. Another thing that I forgot to mention, and this is important, make sure, well, if you're in security operations and you notice that somebody is installing, like compiling tools, this is something you want to keep your eyes open for, right? So it doesn't necessarily mean like, whoa, I'm unhackable. No, but you want to make it a little bit more difficult for the attacker. Don't make it so easy for them. So keep your eyes open for compiling tools that are installed. So this is something that is really not recommended. Comment your code. So yeah, this goes back to what I was saying, that a lot of exploits have normally special instructions or like side notes. And I remember when I was in college, one of my teachers he used to get really, really upset at me because I never comment my code. He was just like, okay, I know what you're doing, but this is not a clean way to do it. ExploitWV, this is an ultimate archive of exploits and vulnerable software, which is a really good resource for penetration testers and vulnerability researchers. I'm pretty sure that everybody has heard about it, but just something to throw in there. And basically we can filter through type of exploit, like local or remote. Like remote would be for privilege escalation, like platform, Linux, Windows, and Mac OS. See, this is what I'm telling y'all. Like even Metasploit, they try to, like exclude it, like it's something bad, like it just makes you gain weight or gives you wrinkles or something. Metasploit is not bad. Okay, SecureWV. This is an additional option that we have, like in Kali. Like I said, Kali is not a must. Like you don't have to specifically use Kali, but it's just an option that it's out there. For example, if I use SecureWV, and it's gonna give me all kinds of crazy stuff, right? So how many exploits are listed for Apache? Tons of them. This is really not the safest bet to go for, because you want to make sure that, like your install is up to date. Exploit suggester. This is assigned with the purpose of detecting security deficiencies for a given Linux kernel, or like Linux-based machines. So it provides the following functionality, which is assessing the kernel exposure on publicly known exploits. So this goes back to, okay, it has to be something that it's already publicly known, right? So it's really not going to protect you for zero-day attacks. Verifying the state of kernel hardening security measures. So it can check for most of the security settings available by your Linux kernel. It verifies not only the kernel compile time configurations, but also verifies runtime settings, giving a more complete picture of security posture. So it's just going to basically let you know if there are any settings that would be out of the ordinary or would expose you a little bit more. This is something that my boss said long ago. Like, I have 3 rules: never roll out a change without testing it, never test in production, and always follow rule 1 and 2. Just basically boils down to don't do anything stupid. So SecureWV files, they're a Linux feature that gives low privilege users the ability to execute a file as the file owner. So it stands for set user ID. For example, if a file was owned by the root user and the SecureWV bit said no matter who executed the file, it would always run with root user privileges. So if it's a file that was owned by root, and like Alice and Bob from marketing get to run it, they're gonna have root permissions. So some of the existing binaries and commands can be used by non-root users to escalate root access privilege if the SecureWV bit is enabled. So there are some famous Linux and Unix executable commands that can allow privilege escalation. So if the SecureWV bit is enabled and I run it, even though I'm not root, I'll get root just by running it. So this is a very generic example. I was trying to look at it and run it, and this is what it would look like. I remember when I was just getting started and I was really not familiar with Linux, and I was just like, okay, none of these applications make any sense to me. It's just like spitting data randomly. So if you see an application that you're not familiar with and it's a little bit more out of the ordinary, or it comes with a version, or, you know, like a folder that you're not familiar with, you always want to investigate that. Running Linux exploit suggester on common set UID binaries, and this is the application popping up again. So just kind of going a little bit through Linux permissions really quick. So Linux permissions are broken into user, group, and other. So user would be like the, you know, like the owner or the person who created the file. Group is the group that they belong to, and other just any other person, like any other user account. So if the SecureWV bit is enabled, instead of having an X in here, we're gonna have an S. So doing our math, you know, like doing our math in here, if we add 4, 2, and 1, it's gonna give us 7. So that's why the typical meme of Gmod 777, you know, like is very popular. So this is a reading only area, 4, 4, 4. We go back to here, 4, 4, 4. R stands for reading. You know, it's funny if they say if you have to explain the joke, it's really not funny, but I like explaining jokes. So this is what I did in here. Just identify SecureWV binary, look for an existing exploit, and if there is no exploit, you just basically rewrite an existing binary with a reverse shell. So I have write permissions to it, and I can write whatever I want. Another thing to do is just find a common exploit for the application. You can go to ExploitDB and click on it. This is the one that I used, and it's a very simple one. So always look for an exploit. EDC password is a plain text-based database that contains information for all users' accounts on the system. It's owned by root and it has 644 permissions. The file can only be modified by root or users with sudo privileges and readable by all system users. So commonly in an ideal world, I should be able to just read it, but not write to it. But if there's a lazy administrator, it could also happen that, you know, like wrong permissions could be assigned by accident. So if I'm able to write to it, I can create a user. So in here, what I'm doing right now is I'm assigning a new user. I'm creating a password for it and appending a new line to create it. I'm appending a new line to the password file. Here it is. Here's the user that I created. Here's just like the hash version of the password. And here's how I'm changing to root. Configuration files. When a target is running a CMS system, it is recommended to look at the configuration files as they often contain sensitive information such as credentials. So even though you're not able to find direct credentials, you want to be able to either find a hash or find a username or find like a version of the system that is currently running or a version of the software that is currently there. It might really not give you a reverse shell, but it might give you enough information for you to gather one. Cron jobs. This is a Linux utility that it's used for scheduling tasks that can be executed at a specific time. This type of tasks run with the security level of the user who owns them. The configuration for cron jobs is stored in the contable files, commonly known as cron tabs. So if this configuration is, you know, like normally created and run by root, if any other user is able to, you know, like run them or write to them, we should be able to have a reverse shell. I'm looking at my cron tab in here. This is me looking at it. This, you know, like 3 entries are extremely common, daily, weekly, and monthly, but you want to be able to see what is below. These files, these two, you know, like files are very uncommon. So if you find an entry that you're really not familiar with, you want to be able to see if you can read or write to it. The thing that I did was just find the location of it. So I navigated to that folder. Replace the contents of the file with a reverse shell. In here, what I'm doing is just completely wiping the file, and I'm echoing the first line of our reverse shell. In here, I'm echoing the second line of our reverse shell, and then I'm just completely writing the shell in here. Since this is already scheduled to run at, like a particular time, I really didn't really have to trigger it or activate it, and I was already getting, like my listener in here. So I'm already root. This is a reverse shell that I always use. Backups with permissions misconfigurations can contain sensitive information such as a private key. A private key is used to identify you to any server that you're connecting to, but it must have like a public key stored into the server authorized key. So it has to have like its matching key, otherwise it's really not gonna work. Some common directories where backups could be found are temp, var, and root. So just kind of showing how it would work from my end. I found permissions to a private key. This is what it would look like, right? So here is my private key, and all of this section from where it says begin just right to the end would count as a potential private key. So if I do something like SSH -I CUCU, I should have given more professional names, and then root at, like I'm terrible with this, 192.168.1.140. ID, and boom, I'm root. So you have to give it the correct permissions, and you have to run this command, and like as long as you have the private key and there is a matching public key in the target system, you should be able to have permissions, like root permissions. So this is how we give it the correct permissions, and then we run this command and we should be all set. Additional resources. I know this was kind of like a weird talk. I'm sorry if I put you all to sleep, but this is something really interesting. Like I said, like the privilege escalation entails a lot more steps, but I was just trying to squeeze as much as I could. But yeah, and if y'all have any questions for me, or like you have a good meme to share, just definitely reach out to me on LinkedIn. And yeah, cool. Well, thank y'all so much for joining me. Too long, didn't read. Sorry.
No, thank you. Thank you for your time. There's a lot of information. I want to ask you a couple of quick questions. There weren't any questions in Discord, but you started out with a conversation about the security and or IT teams being offended by privilege escalation. And I find that interesting because I get that attitude sometimes from IT teams. It's like, oh, you can't do that. Well, actually, and I think your quote there was the best. Boom, I'm root. Because I do that to people and they're like, you can't do that. Yeah, well, this is how the exploit works, and this is how we wrote to a file we shouldn't have been able to get to, and boom, I'm root.
Yeah, so what I've noticed the most backlash on is the use of Metasploit. Like they talk like it's just something, like it's just like murdering puppies or something. No, well, it's not a bad tool. Just
well, and I see Cobalt Strike. At this point, I see that a great deal when people try to land and beacon on our network. It's my honeypot picks up Cobalt Strike payloads, and I'm like, okay, that's a known issue. So anyway, I do really appreciate your time. And your expertise here has been invaluable. We really appreciate it, and we'll reach out. Thank you, Melina.
thank you. Okay.